Howdy tubers, welcome back to another Zach Live Machine Shop edition. So we're back up here in my machine shop and going along with the last video of this tire hacksaw. I want to get this old welder running. So real quickly, I realize my channel has got a lot of variation in my content, and I know there's some aspects of it that someone might like and parts that they don't. And there's actually a playlist, and I take all of my videos regardless of whether they fit in a category or not, and I put them into one of those playlists. And if there is something about my channel, whether it's only oil field or only up here in the machine shop or only my motorhome or whatever, you can use those playlists as sort of like a subset of my channel, I guess. You can only be exposed to the parts you like or whatnot. And anyway, I want to start a new one about this machine shop, and I'm going to go back and retroactively put into it all the videos that had anything to do with this machine shop up here. And so if you're interested in seeing more of this, you can go click on it and see it. Enough of that for now. So I've got this old welder, and this thing used to run and used to weld. After I was shortly out of high school, I did actually use this a little bit. But the contactor burned up, hadn't ran in a long time. I got another cheap Amazon contactor, and I think that it is wired correctly, and I think that it is ready to run. It's a 200 amp Lincoln stick welder. There is not a lot of information on this, and it is extremely old. But anyway, I'm ready to see if this thing will go. I would like to grease this thing really quickly. I guess it's only got 2 bearings. It moves. So it's got a rotation tag on it. It's supposed to run in that direction. I guess this thing's ready to go. I'm a little bit afraid something might blow up here, but let's see what happens. It's even going to go the right way. Well, would you look at that? It's amazing old stuff that just takes off and runs. I just realized this is actually a piece of slate. Is that not the coolest thing ever? I guess. I think that's what it is. Man, how has that thing survived all these years and not been broken? Yeah, that's what that is. That's a piece of rock. This is the next day. I want to run back up here and kind of give a little bit of history about this machine. It's got an interesting history. I need to talk about its controls. I didn't really get that done yesterday. I've said this before. My great-grandpa bought this property. I believe it was 46 or 47. I don't remember which year. But this welder, my grandpa was telling me the story, was sitting in a shop that was just on the opposite corner of this city block. And it's got kind of an interesting story. In the early 1900s, a fellow by the name of Hughes invented and patented a new kind of drill bit to drill oil wells with. It was called a roller cone bit. It was originally a dual cone bit. He later invented the tricone bit. But he had a patent on it, and he didn't allow any other companies to build these bits. And there were these little machine shops that popped up, and it's where this was. I don't even know that I would call them machine shops, but they were little bit shops. And they were usually, by my understanding, my grandpa telling me the story, decades ago, they were usually little small shacks that might have been like a one-door service station, gas station or something. They'd find an old building and they'd put these little shops in it. The press and a welder and a lathe and whatnot. And they would take these roller cone bits apart and put new bearings in them or bushings or whatever was in them, and then take hard face welding rods and they would reface all the little tips of the roller cones, and they would rebuild these bearings for literally pennies on the dollar of what you could buy a new one. And my understanding also was that the Hughes company, Baker Hughes or whatever it was back then, actually leased the bits. They wanted them back when they were done. And so it had to be a very fast operation. You leased a bit from them, you ran it, you had it reworked, and then reran it, and then turned it back into them, or something to that effect. And anyway, that's where this machine came from. The oil field kicked off around here in about 1920, maybe late 1919. They started drilling a few wells, but it really took off in the later part of 1920 and in 1921, and its probably peak was about 1923, and then by the mid 20s it had sort of slowed down, or at least it quit booming. You know, it was no longer accelerating or growing or whatever. Anyway, I would date this machine by that to probably be about 1920, 1921, 22, 23, something like that. I think that later on in the mid 20s, at least around here, the Hughes Company actually had people that looked for these shops, and they policed it well. And I think that becomes sort of a thing of the past, that they really were able to shut down and sue, and you know, whatever they had to do to keep little businesses like this from rebuilding drill bits. Anyway, by that story, I suspect this thing is probably like I say, early 20s. Everything seems to be relatively free. I wonder if it'll weld. To increase resistance. Look at this old ground lead thing. It's a homemade piece of pipe. I guess that's probably soldered in that piece of pipe, and then got that tang welded on it. I went and got a welding rod. I don't really know what else to do other than try and see if this thing will weld. I've set this sort of on the second notch there, and this is rheostat sort of in the middle. Let's crank it up, and you know, I already got a rod in here. The rheostat was turned all the way in the direction I would say is up, clockwise. I'll turn it the other way and see what happens. Oh, that rheostat definitely works backwards. Hey, look, the amp meter works. Hang on. You don't see the amp meter? It doesn't look like the voltmeter works, but the amp meter does. That thing is putting out the juice. There's still a rat turd riding on that brush over there. Okay, so I worked on this for about an hour here. I got my little air compressor over there aired up, and I kind of tried to blow some dirt off this, clean it up a little bit. I wiped the commutators off real good, both of them, kind of cleaned those brushes up back there, clicked them in and out, sprayed some stuff on them, and just generally tried to clean it up. I took and swept under it. There was this box used to be there, and I moved it there. It's full of some old junk connections, like little bitty nipples and stuff that probably needs to be thrown away. But my trash can's full, so that's for another day. So the only reasonable way to end this video is to weld something. I just made this on the lathe. Quick montage. So what this is, real briefly, if you can imagine an oil tank. I've talked about it. There's stuff that settles out of the oil that settles in the bottom of the oil tanks, and we have to clean it out. The side of a tank at the bottom, you know, relatively close to the bottom, has got either a 3 or 4 inch, some of them are 2 inch, steel connection welded inside of it. And that's how you clean the tanks, is you suck the crap off the bottom from that connection. The problem is it's generally a 3 inch, and it's far enough off the bottom that there's room to get all the way around and weld it, and the top of that connection ends up being about 6 inches. Now, if you get 12 inches of crap in your tank, they won't pick up your oil, because that's where the pipeline connection is. Before I started machining on this, I chucked this bushing up just a little bit cockeyed, and so it's sitting there running off center. And what that does is when you bore a hole through it, it makes the hole just a little bit crooked. See, you can see how that bushing's offset. And so what I'll do is screw this into the tank, and on the inside piece of it, I will screw a piece of PVC that's about 4 or 5 feet long. And when you get it in the right orientation, like that, it will have that 2-inch PVC basically laying on the middle bottom of the tank. Let's weld this up. I don't have any idea about what kind of current this is set on. I guess we're gonna set that in about the middle. That's on medium, and I don't know, let's go try to weld something. So I just realized something. I bet that this was their welding table. It's actually cast iron. I'm not really sure what this, I don't know. I don't know what it is. It's something with a couple big holes in it. It kind of looks like the end of a spool, but I don't know why you'd have a cast iron one. But they've had this deal, and I've always wondered what the heck was up with it. And I think that they've welded that thing on there, and this is supposed to stick in there. I guess that's a welding table. I'm just gonna have to weld a little bit and then adjust my current. That's probably just a very little bit cold. That's pretty dang close though, honestly.
The thing's not welding very good. It's so sporadic. I don't know if you can hear that. It's kind of sprouting. It's a little bit cold.
Yeah, it looks really cold. It didn't seem all that cold. And that's really weird. The puddle's not wetting out like normally, but it doesn't seem cold, and it's kind of throwing BBs like it's a little bit hot. I'm gonna dunk it in some water, get it off. So I just rinsed this off. I hadn't brushed on it or anything. This isn't the worst looking thing I've ever welded, and it probably will, I mean, it looks okay, I guess, considering. But the welder sounded really weird. I don't know, it's hard to explain, but it was like the arc danced around or something. It just sort of, wish I had a hood you could see it. It kind of felt cold, like the puddle didn't wet in good, and the arc wasn't real stable. It sort of, I don't know, it's hard to explain. Not really moved, but it just was kind of erratic, you know, I don't know. But anyway, this was the first part here. This was way too cold, and I could tell as soon as I welded it. I turned it up here quite a bit. Where's that other tie-in at? It's right there. So from here to here, turned it up quite a bit. It sort of felt hot. It was sort of throwing BBs, you know, like 18 will do when you're a little bit too hot. But it still didn't wet in. I don't know. It's still kind of crowned up. You can see like it looks too cold, but the you know, arc seemed pretty hot. I don't know. And then I cranked it up some more from here back to the end, and this looks pretty good to me. But I don't know. It's what it is, I guess. I'm going to give you a quick rundown of how this thing works, because it's kind of interesting, I think. The main controls here, this is just a disconnect. It just kills the power to the leads, and I don't really understand even why this is needed, but that's the main kill switch. This switch here gives you 3 different levels, like a low, or this would be a low, and a medium high, and an extra high, or whatever. This big rheostat has what sort of is the fine adjustment. Now, I'd like to talk about how it actually does that. So before I jump into this, you need to know just a little bit about stick welding. And basically the only thing I want you to know is that when you stick weld, you need to have a relatively stable current. The amount of amps that's going through the wires, through the machine, and through your arc has to remain relatively stable. And that is regardless if you strike an arc and try to hold a long arc, or if you have a short arc, or if you stick your rod. You know, if you stick your rod and you had a normal type of DC generator, it would just produce a, you know, uncontrollable amount of current. The generator would burn up, the, you know, rod would explode, you know, it would lock it down or whatnot. And these machines have to be, that's one of the big differences in them, they have to be able to self-limit their current if you stick the rod. You don't want to just stick the rod and it go to 2,000 amps, you know, and blow something up. So this machine is divided into 3 pieces. The center piece here is a plain squirrel cage induction 3-phase motor. It's nothing unusual. The only difference is it's got stuff basically hanging off each side of it. We can look at the tag here. It's got the serial number, we'll go over that in a minute, but it's just a 10 horsepower, 220 volts, 25 amp, 3-phase, 60 hertz, 1800 RPM, 3-phase motor. Nothing unusual, nothing special. On this side, it's got a self-exciting 1800 RPM, 110 volt DC generator. Now this is a self-exciting without a regulator, so it's not going to have a very stable voltage. When you increase the current, the voltage goes down. It doesn't matter in this situation, but this is not really something probably you could run like lights in your house off of, because the more lights you turned on, the dimmer the other ones would get. This is a very simple DC generator that makes about 110 volts DC. So this end here is the main DC generator. This is what actually produces the main DC power that's used to weld with. These brushes here are what collect that main DC power off of this commutator. We'll go over this more in a minute, but this is the actual output. This post here is directly connected. This is the negative, I believe, is directly connected through some cables back to the ground cable. It goes through the machine and back to right here, and there's a big copper bus bar that connects this to this. So we got a negative and a negative, a positive and a positive. Now the next thing you need to understand is that the output, the current output of this commutator, these brushes that are going to the welding leads, is directly proportional to the strength of the magnetic field that's produced in the field coils. And these are the field coils, coils you see on the outside that do not move. This rotor part here, this part moves. The stronger the magnetic field that's created by the field coils in this big generator, the more power this generator puts out. The more voltage, the more amperage, the more everything, the more power. So the output from the exciter generator in the back here goes through this rheostat. And the rheostat is not unlike a dimmer in your house. It doesn't work the same way, but it does the same thing. And it limits the current that goes through the field coils. Now this current is supplied through the rheostat, through these 2 small wires down into this generator. And if we look in here, there is a coil. There's a coil here. You can see it's got all the small windings. There's one here. There's one every 90 degrees. There's one down there and one cross over there. These field coils are the initial control of the output of this welder. And so as you turn the rheostat down, as you numerically to a lower resistance, that causes more current to go through these field coils. That rheostat controls the initial setting. Now what makes this really cool is a thing called a set of series wound field coils, or opposition coils. That doesn't sound like the right word. So we've got the negative output of this welder comes through here, and it goes into a coil that's 90 degrees that would actually be 45 degrees off of the main exciter coils here. You see there's one there, and then it loops around, there's one at the bottom, and then the positive coil goes through two more, one here and one up here. And so what this does is when you strike an arc and you pull power, when this thing generates current and it goes through these opposition field coils, these coils cancel out this initial main coil that's controlled by the exciter generator. The more power that this welder produces, the less it tries to produce. Does that make any sense? Because the more output that goes through these coils that are going to the welding leads, the more power that goes through those, the more magnetic field they create to oppose the field coils. It's a self-limiting generator. Now where this gets to be really neat, there's more to it than that. As this is, just like we're describing it now, would be in a situation where this is at its minimum. The output from the plus and the output from the minus both go through those opposing coils. We got a negative and a positive. It goes right back over here, basically to the back of this switch. What makes this cool though is it takes part of the positive and it splits it out down there, and you can see there's like it's probably like a Kearney clamp or something right down there in the bottom, and it takes that wire and it goes up and to and around right here, and it's got another coil that actually is wound in the original field coils, lined up with the original field coils. Now those make a lap and go through all four field coils, and it comes out in this third wire. That's why there's two positives that are smaller and one negative. And it takes this second positive wire and it puts it into this big giant resistor. And you pick up more or less of this resistor. When you go all the way in, it bypasses this resistor. So at this point, half of the welder output is actually going through this coil, which now is adding magnetism to the original main field coil instead of going through the opposition coils. So basically what it's doing when you've got this in a full blast or one in between with the, some addition of resistor here, is that it's using some of the welder's output to add to the magnetic field, which cancels out the opposition coils that take away. So you kind of add and take away. It's a, whatever, you got a lot of opposing magnetic forces going on in there. Hope that made a little bit of sense. It might be easier to understand if you had a diagram, but you just got a three-phase motor that drives all of it with a exciter generator, which excites the field coils in this big generator, and this is what makes a welding current. And it's just got some kind of ingenious designs in here with some opposing magnetic fields and stuff to self-limit its current or give you a much more stable current. Here are the three tags. This is the motor part, this is the exciter generator, and the last is the main generator. If y'all can figure out how old this thing is or come up with some numbers, let me know. Okay, so I figured out a couple of things too. I have ran this thing probably about an hour, and I've made it weld much better. I think initially you could see some sparks and stuff that would kind of come off this commutator, some little piece of dust on fire or something. I'm not sure what they were. And I think that these had just set so long, that was the first 10 minutes that this thing had ran in over a decade. I think this just sort of needed to get reseated, and the arc got much smoother. The other thing that I figured out was that the polarity was backwards, is still backwards. I haven't switched it around. If you look, it's got a cooling fan in here, and you can tell that something must have been dropped in there, and the cooling fins are all laid over like it was turning this direction. Well, it's got a rotation tag, and rotation is this direction. Well, I made it run this way, and I think probably that this thing used to run backwards, and I guess I don't know this, but I guess that if you turn this the opposite direction, it probably would reverse positive and negative polarity. The only thing I really like finishing this is I'd like to put a cover on this. It's obviously it had one at some point in the past, but it's nowhere around here. They probably welded it to something or used it for a piece of plate. But I need to get that done. Other than that, this thing runs and welds. It'll do what I need it to do up here. I got to get me a set of bottles and a torch. But kind of getting this place close to what I want out of it. Make something I can use instead of being something that just barely works. I wanted a shop up here that worked well. Anyway, I'm done rattling. Appreciate y'all watching. Appreciate the support. Like it, share it, thumbs up, bell thingy, whatever else. Catch you on the next one.